So many young people keep messaging me for more details on how to build a motorized bicycle. Well, everyone's different because who knows what kind of bicycle you're going to use or what kind of motor you're going to use. I happen to use this bicycle because I found it in the garbage and it was in working condition. The next infinitely important thing when choosing an engine is that you choose one that has a clutch on it. Only half of the weed eaters made have clutches on them, and they're usually only the better quality ones. The clutches on weed eater motors all look a little different, but all kind of work the same. You've got to figure out how to attach a small sprocket, like for example this 11-tooth sprocket, to the end of your clutch. On this model of engine the clutch is fully enclosed, and other ones you can still start it and have part of the clutch sticking out so you can see what you're working on. Well, some clutches have a square hole in the middle, and then you can make, like I did on this one, a sprocket with a little shaft attached to it with a little square shaft that goes into the hole in the clutch. And so that the little shaft doesn't fall out of the hole in the clutch, I've got this little end, it's called an end stop. It just stops the shaft from sliding out of the clutch hole. Here's an old chainsaw to give you an example of what a clutch looks like. It's a freewheeling cup-shaped disc. It's got a bearing in the middle and weights that fly out when you rev the motor that grip it and start to spin this part. Well, on a chainsaw you have this funny little cog thing right here that grips the chain and spins the chain around. Well, that's absolutely useless if you're trying to make a motorized bicycle or anything else. I used to be a machinist, so I start from scratch and I just make a whole new cup and a sprocket and everything all from scratch from one solid chunk of metal, and I machine it on a lathe and a milling machine. But most of you young guys don't have access to equipment like that because you're talking about $10,000 worth of equipment just to make a clutch. It is possible. Take off, for example, on this model, the big washer. Either grind, this one's got a removable cog, so you can just remove it. Or if it's not removable, many of them aren't, you just have to grind off all the drive teeth with a grinder. You try to grind them off really evenly so you have a concentric circle in parallel with this one. Well, whatever method you use, once you get rid of this wrong type of drive cog, whether you grinded it off or you've removed it, then you've got to buy a small sprocket, say anywhere from 10 to 12 teeth, to somehow attach to the bell cup. Well, you may have to open up the hole inside the sprocket to make it big enough to fit over top of everything here that you have left. Well, you can do that by drilling or grinding. It's a pain in the butt. Then somehow you have to attach that sprocket to here. Well, brazing it with a brass rod and an acetylene torch might work, or on this 90-degree edge where the new sprocket would be sitting on, you could MIG weld a weld all the way around here, and that might be able to hold it on. Make sure the bearing isn't in there while you're welding or you'll melt your bearing. On my motorized skateboard, as you see here, this is the clutch that I made. It was filmed out of one complete block of steel. It's made out of hardened tool steel. I machined all those little sprocket teeth, machined a bearing surface inside for the little roller bearings. Well, that's way beyond most people, so you'll probably just have to try to figure out how to weld a sprocket that looks like that to the bell housing of the clutch and get it centered. That's very important. The next step on your project is mounting the motor. Well, every weed eater has a different way to mount the motor. You've got to figure out a way because there really isn't a way. So I've got a bar here that's welded to the frame, and I've got an angle plate here that's welded to the frame with a little support bracket so there's no twist in the motor. So, as you can see, the motor, this plate, I had to cut up here through the middle of the motor. Got a couple holes drilled in it to attach to holes already that were existing in the block of the motor. Plate runs at an angle and is welded to the frame. At the front end of the motor, there's the vertical plate that welds to the bars, and a little T-plate that comes off that is welded to here. And found some places on the engine where there was existing holes, so drilled a hole in this little bar and made it fit the engine. Of course, everyone's going to be different. Make sure you know which way your engine's spinning when it runs so you don't put your engine on backwards and have your bike go backwards. The throttle is just a shortened brake handle. The cable is just a bicycle cable from the brakes. Where the cable attaches to the motor Had to make a little metal bracket as an end stop to hold the cable in position. And my weed eater had a little tiny piece of elbow on the end of the cable that went into the hole on the throttle. Well, of course, a weed eater throttle cable is a foot long, and you need something about 3 feet long, but you also need that special little end that goes in the hole of the throttle linkage. So here's how you do it. You cut off a little length of weed eater throttle cable with that special little end, say maybe that long. Then you cut off a little piece of copper pipe as a coupler. Then you get a piece of bicycle brake cable and figure out how long you have to make it once it's in position. And you slip that little copper coupler over the piece of bicycle brake cable, slip in the little piece of cable you cut off your weed eater also into that little copper sleeve, like I just mentioned. Then put it on the ground and smash everything with a hammer. That will couple the 2 cable pieces together, and then you have something just like you see there. And you can see that little part I squished together to join the 2 cables. Every weed eater has a wire that goes to the kill switch to shut it off, so you just unhook it from the kill switch, run the wire up the frame to another switch. One goes to the switch, one goes to the ground. So when you push it, it stops the motor. Now the next trickiest part is remove the pedal crank mechanism completely and bearing cups. And you have to get a couple sprockets and a couple precision sealed bearings. Here's a tiny example of what a precision sealed bearing looks like. Got some plastic around here that holds the grease in, and common size you would want to use for your crankshaft that goes through the middle there would be a 5/8 hole in the middle and an outside diameter of somewhere around 1 1/4 inches. You can easily find these at bearing supply places. So you look up bearings in the yellow pages. In my city, I went to CBS Equipment. They have bearings, belts, sprockets, chains, and pulleys. So every city has companies like this that specialize in drive equipment. The 5/8 inside diameter 2 bearings in there only cost about $7 each, so it's not a big deal. The big deal is they don't fit inside here, they just flop around loose. They'll only fit your shaft perfectly that goes through. Well, if you see that metal edge and that metal edge, that's a cup-shaped device I made. The bearing sits in a pocket in a machine cup that presses into the crank cylinder of the frame, and that's the lip on the edge that sets the distance that it presses in. That part you have to make from scratch on a steel lathe. Well, you're at your bearing supply place. They have every kind of sprocket you can imagine. The best kind of chain and sprocket to use for making a motorized bicycle is called 3/16 roller chain, or it's also called number 35 chain. This is just called a flat steel plate sprocket. It's got no drive hub on it, and they come already with a 5/8 inch hole. So you can just stick your shaft through it, put a weld on it, and attach it to the shaft. Simple as that. That sprocket costs about $9. On the other side, I got another sprocket. It's about 15-16 teeth, but all the smaller ones come with a little drive hub on them, and most of them come with a 5/8 inch hole also. So that works out perfect. Slide it on the shaft, put a little washer in there to space it from your bearing and your bearing mounting cup, and tighten the set screws or put a little weld on it. This sprocket assembly that's in the middle of the bike on the crank is called a jack shaft assembly. Well, I got exactly the same kind of 6-inch sprocket and bought another one and put it on the back. You cannot use a small sprocket on the back like it originally comes with your bicycle. The gear ratio will be wrong. So I'll show you how I attached this sprocket to the rear wheel. On this particular bike, it just had a single sprocket. I had to grind out the hole in the middle of this sprocket, or any way you can think of making the hole bigger so it fit onto the sprocket hub. Then I drilled 3 holes that happened to fit between the teeth, the original sprocket, and put a little nut and bolt. Now you can barely see the nuts on this side, they're all dirty. The best way to increase the size of the hole in this sprocket is put this sprocket in a lathe, spin it around, and bore the hole out with a boring tool. That's actually how I did it. So, the ratios. That gear is 4 times smaller than this gear, and this gear is 3 times smaller than that gear. So that's 3 to 1. That's 4 to 1. When you multiply that together, 3 by 4, you get a total of a 12 to 1 gear ratio, which means if I rotate that motor 12 times, the back wheel will turn once. That's very important. Weed eater motors run around 7,000 RPMs. And with your fat ass on them riding them, and they have limited horsepower, they're only going to do about 25 or so, maybe 30 miles per hour. So that's all the horsepower output they got. So that gives you a gear ratio where that motor is running at 7,000 RPM to go that speed. If you use a mountain bike, like one of those, they've got a bigger wheel. So instead of a 12 to 1 gear ratio, you might need a 13 or 14 to 1 gear ratio. So you just got to get different size sprockets and just do that simple calculation. Some people like to use friction drive. They mount a motor over top of the rear wheel someplace back here, have a roller on the shaft of the engine that's say 1/12 the diameter of the wheel, and it presses hard on here to try to get enough friction to drive the wheel as everything's spinning. Well, this method sucks. It wears your back wheel out quick, it slips when you go through a puddle, and it robs horsepower from your engine by all the downforce you need to get traction. But of course it's by far the simplest method. This is the most complex method, but it's the most ergonomically pleasing. You know, it looks the best. It looks, it's very comfortable to ride. It's well balanced. It only adds about 4 or 5 pounds to the total weight of your bicycle. So I would prefer this method, but you need to have access to a welder, a drill, a hand grinder, and of course maybe a lathe and milling machine. So let's see if this machine starts. It's been sitting a while. Got it on half choke. It's always on until you push the kill button. Give it a yank. Oh, wonderful. Now as you can see, it's not going anywhere because it has a clutch. If I rev it up, the back wheel starts to spin in the way it wants to go. And we're off. Well, simple as that.